So, good morning. Welcome to our session on what's new in Android development tools. My name is Jamal Leeson. I'm here with Zav and Tor. And today, we're going to give you an insider's tour of all the new and upcoming features for Android development. As you know, Android Studio is the official IDE for developing apps for Android, provided by Google. We work hand in hand with the platform to ensure that all the latest APIs and features are tightly integrated inside of Android Studio. It's our team's mission to ensure that we provide the latest and greatest tools to help you be efficient and productive developers. I must say, I thank you for your feedback so far in making Android Studio great. So before we jump into new features, I just want to spend a few moments talking about features that we launched since we last spoke with you last year, in case you missed them. So last year at I/O, we gave you a preview of Android Studio 2.2, which included things like a new layout editor, the Espresso test recorder, and CMake support, which is great for C++ projects. And around November, we gave you a preview of Android Studio 2.3, which included things like an update to Instant Run, the lint baseline support, and the constraint layout reaching stable status, which is tightly correlated with the layout editor. And this past March, we actually released a few releases of Android Studio 2.4. But as you know from yesterday, we're not going to be releasing Android 2.4. Instead, we're releasing Android Studio 3.0. So we made this shift for two reasons. Number one, as we were developing features, we realized all the work we're going inside this release didn't seem sort of indicative of one incremental change. Number two, we made the tough and rare decision to make a breaking Gradle API change. And we'll talk about that. But that change allows us to scale and have faster Gradle build speeds. So we have features across the entire range of feature sets for your app development, from building, testing, and optimizing your application. So let's dive in. But instead of me talking about it, I'm actually going to invite Tor up to give us a demo of all the cool features inside of Android Studio 3.0. And after that, I'll have Zav come up and talk about the build system. So with that, Tor, let's get started.
All right. So this is Android Studio 3.0. It's based on the latest version of IntelliJ, a latest stable version, 2017.1. So we picked up tons of great features that I'm not going to have time to show. I'll just highlight a couple. There's parameter hints, which you see here, where we show the parameter name at the call site. And there's emojis in comments. So sometimes when you're commenting on some slow code, you really want to use a snail emoticon. All right. Anyway, the big news for us is that we are supporting Kotlin. So in the new So in the new project wizard, there's a checkbox now. You can enable Kotlin right from the get-go. Or in an existing project, you can start creating Kotlin files directly, and the IDE will walk you through upgrading your project dependencies. Or you can just take an existing class and run it through a converter. So the way you do that is you go to code, convert Java file to Kotlin file. It runs it through this converter. And sometimes it does a fantastic job. Like here, it's realized I want string interpolation, and it's used destructuring declarations here. But you can see also sometimes gets warnings. It's not always perfect. I want to lower expectations a little bit. Here's another example. Here we have a data class in Java. There's a one-line version of this you could write in Kotlin, but if you run it through the converter, you end up with code that is completely accurate, but not the most optimal. So this does the same as before in Kotlin. So it's really a great starting point, and then typically you massage it a bit more. So here's a Kotlin file showing several language features. You have the for loop with ranges. You have a let statement with a lambda, and you have a when statement. We don't have time to cover the language today. There's going to be talks about that tomorrow that you don't want to miss. But when you're starting out, you might have some concerns about performance here. Like, is this going to be expensive? What about this let statement? Is this making a new inner class and an object? There's a really great way to find out. So you can invoke the show bytecode window. This is going to show the bytecode for the current statement. If you read bytecode, that's great. But if you don't, there's this really great decompile button in the top right window here. When I click on this, I get the equivalent Java code. So now I can look at this and go, OK, that range loop turns into a really pure while loop with an index check. And similarly, the let statement is just an if check. So don't prematurely optimize in your head based on what you are afraid Kotlin's going to do. Write, the most beautiful Kotlin code you can, and when you're in doubt, you can check what it's doing. The last thing I'm going to say about Kotlin is that all the Android lint checks that ran on Java files, there's about 80 of those, they're all running on Kotlin as well. There's no gap. It's the same code base now. All right, let's talk about the layout editor. So we launched the new layout editor last year at I/O, and we've continued working on it, obviously. So one of the things we have in the new version is better handling of errors, as you can see here, and constraint layout. We've enhanced that a lot. So first of all, we recently added chains. So a chain is a way to distribute widgets along an axis. So you can select these 3 widgets, say that I want to create, for example, a horizontal chain. I don't know if you can see, but there's kind of a beautiful chain graphic here. And I can align this horizontally. And now there's this chain cycle button. So I can basically click on this to explore how the chains are behaving. Another feature we're about to launch is constraint layout 1.1. And in 1.1, we have barriers. And the easiest way to explain this is just to show it, I think. And so if I were to move this widget, you can see that this line next to it, basically, we make sure that we don't ever overlap with it. So this is a pretty good way to make layouts that respond correctly. And that's actually all I'm going to say about constraint layout, because there's a whole talk about it in a couple of hours that you don't want to miss. Another feature we've added in the layout editor is support for sample data. So in your apps, you might have a list view or a recycler view. It's pretty common. And it looks nothing like the layout editor when you run, because you're putting data into it, images, and of course, application-specific data. So a couple of years ago, we added some support to deal with this with design time attributes, the tools attributes, right? So you could put some string in, and you can start approximating what your app's going to do. But that's terrible in a list view. So we've continued enhancing this. So now we have this new sample resource type. So for example, I can pull in some lorem ipsum text, or I can pull in, let's say, date of the week. But the real power of this is when you actually define your own data. So here is this new JSON file that I've created in my project. This is for a fitness app. So there's various activities that this app is modeling, biking, walking, and so forth. And there's some other data associated, like distances, and we even have some icons. What I can do now is go into my item layout that I'm using in the list, and I can start binding these things. So code completion works here for the @sample tag. It's picking out all the attributes from the JSON file, and I can, for example, hook up the icon property to this. I can hook up the description property to this next text view. And so when I come back to this, you can see I get a layout that looks much more like the real app. All right. The last layout editor feature I'm going to show is support for O downloadable fonts. So in O, you can declare downloadable fonts. There's lots of advantages, and there's a talk about that as well, of course. But the way this works is that I select a text view, and in the layout editor, in the font family chooser, there's a more fonts item on the bottom. When I invoke that, I can browse the available online fonts or search. I'm going to pick my favorite, Fingerpaint. And you can see I now get this new font resource in my project, and it actually works the way you'd expect. All right, another O feature we've added is support for adaptive icons. So in the image asset wizard, we now help you create these. So we help you with the foreground layer. You can modify the background layer. I don't know if you can tell from the screen, but there's also options to show safe zones, grid, and so forth. So this hopefully helps you put all the right bits in the right places. Another small feature that's easy to miss is the bottom right corner here. There's a device explorer now, finally. So here you can go in and actually explore files on your file system. You can click on files to see them locally, and you can right-click on folders to upload and download files and that kind of thing. All right, let's talk about, thank you. Let's talk about instant apps. So we have a lot of support for instant apps. We have a bunch of new lint rules. We have support in the Gradle build system, which I think Zav will talk about. We have new wizards for creating feature modules. But the hardest part of creating an instant app is probably going to be to break up your monolithic app. So we're working on some refactoring tools to help with that. So I'm going to take this simple example first. So here I have a class. I'm going to extract it. So I invoke the modularized refactoring. And you can see that it offers to pull 4 classes out into this new module. And that's because this class depends on 3 other classes recursively. And it'll also pull along with it resources and manifest entries. This is the ideal case that I bet you will not actually encounter with your own app. Here's some more realistic example. So I'm going to try to pull this activity into its own module. And here you can see it's pulling a lot. And we have some spaghetti because my class depends on this class, which then, utils class, which is then pointing into some other stuff. This is real spaghetti. And so what you have to do now is start deciding where to cut the spaghetti, right? And so you invoke this, it creates a new code, and then you would have to actually fix the code afterwards. So we have an initial version of this in Canary 1, but this is a feature we're very much still working on. We've also improved the APK Analyzer. So what I can do here is load in a APK that is a release binary. Right. So last year we launched this and we had a lot of support for resources. This year we've added a bunch of support for code and DEX. So first of all, I can drill into the DEX system here. Let's see. So I can right-click on a class and we disassemble the bytecode for you. You can also notice that the package name here is a.a.a, and I promise we didn't write the code that way. That's because this is a pro-guarded APK, right? So ProGuard has gone and shrunk all the symbols down to something very short. But now we have this button for loading the ProGuard mapping file. So when I do that, I've got to find my ProGuard mapping file. When I do that, you can see that we now show the original symbol names instead as you're drilling around on the DEX file, which is pretty handy. There are some more features here. I can right-click and, for example, generate a keep rule, which is handy when I'm comparing debug and release binaries. By the way, we have this compare button up here on the right. And I notice that, hey, I need to actually keep this class for the release. Or conversely, I might be surprised that this class is in the release binary. And so I can right-click and say, show me the usages in the pro-guarded code to help me identify what it is I need to get rid of. We have another feature for APKs, and that is APK debugging. So the way this works is that either from the welcome screen or from the file menu here, you can point to a random APK. Let's see. I don't know why it's not showing my home folder. I think I'm having network issues. Well, this is very sad. All right, I'm just going to talk through it. So basically, if you're not using Studio, if you're a game developer, we give you a way to just point to an APK, and we make a shell project for you based on the APK Analyzer, where we show you the sources inside the APK on the left, and then we let you map sources, the Java source code, as well as the shared libraries. We let you drop in a SO with debuggable symbols to stand in place for the optimized one. So I'm really sad that didn't work. All right, next, I should talk about the profiler. This is a really, really big feature for us with lots of people working on it. And here's how it works. So I've already started running my app. It's an image app. In fact, you probably saw this in the keynote. I started running it. And so the way the profiler works is I can now open up the profiler tab, and it will attach to the process. All right, no connected devices. I'm going to run it again. It's very unhappy. I'm going to just kill the emulator and start over. This is really exciting television, isn't it? All right. We should work on making that system image boot faster. All right, so here we have it, and no connected devices. Wow. You know what? I say we. Oh, there we go. Here we go. Whew. All right. OK, so the way this works is that it's attached to this process, and it's showing me what's happening with the CPU, memory, and network. And so let's go and make some stuff happen in the app, right? So I'll click on an image, and wow, network is very unhappy. OK. All right. Super slow. OK. Anyway, it works, because if we look in the background here, and I accidentally clicked on the memory profiler, here we have the CPU, memory, and network. Do you see these little purple dots up here? Those are my touch events. You can also see the activities happening. Things like stopped and destroyed. It's very small, but it's basically listing the activity names up here. So let's start with the network. This is a timeline I can scroll in. So I'm going to click down in the network area, and here I can see the network traffic and radio traffic that happened in this time interval. I can zoom in on something like this, and it'll show me the network calls that happened during that time. And I can click on a particular network request and sort of see it and the call stack. And the way this works is that we instrument your app at build time. And so you have to opt into this. So you go to your run config, and there's a profiling tab where you enable advanced profiling. So basically, we look for usages of HTTP URL connection. And so if your app is using that or anything based on it, like Volley, and we also support OK HTTP now, as of 3.0 Canary 1. We've also added support in Android O for basically doing this instrumentation on the fly. So you don't need to do any kind of build time instrumentation. So that'll be enabled in an upcoming build of Android Studio. All right, so that's the network profiler. Let's look at the CPU profiler. All right, so I'm going to, again, click in here. And here I can see the thread activity. So I'm going to jump to be live again. And then I'm going to do some stuff in the app. So I'll click on this image. Actually, I forgot that what I want to do is start collecting samples. So I'm clicking on the recording, and now it's gathering more information. And then I'll do some stuff in the app, like that. And now I'll stop recording. OK, so now the timeline is showing me here that during this interval, we have more information. And I can stop. I can click on a particular thread I'm interested in. So the thread displays in the middle here, and we can see that async task 3 looks pretty interesting. So I'll click on that. You can see a flame chart on the bottom here. And this is actually based on ranges that I select. Right? So I can narrow my focus on what I'm particularly interested in. And we also have, actually that was the call chart. This is the flame chart. And we also have top-down and bottom-up displays of the frames. So here I can sort in descending order of method calls, for example. So that's the CPU profiler. And last but not least, we have the network profiler. So again, I'm going to go live. So I just want to reiterate this point about this timeline keeping all data. I think I was told about 5 megabytes per hour is what this costs. So now I'm going to go live, and we're going to start looking at memory. So the first thing I'll do is I'm going to go inside the app, and I'm going to ask it to clear all of its caches. And then I'm going to go into the network profiler, and I'm going to click on the garbage collection. So now we have sort of a good baseline. All right. So this is showing you the memory of the app right now. And let's start collecting allocation stack traces. This means that any kind of allocation that happens in the app, we're going to record where it was done. And the reason for that will be obvious in a second. And now I'm going to do some more memory-intensive activities in the app. You can see in the background the metrics are scrolling as it's realizing the heap is larger. And now let's go in and grab a heap dump with this down arrow here. So now it's fetching a heap dump. And that should be fast. Yeah. So here we can see basically a summary of the objects in the heap. If I click on, for example, the bitmap class, there's 76 bitmaps. I can see those objects here. I can click on a bitmap class, and just like in the old heap viewer, I can now start chasing down the references if I want to look for a leak. But I can also see which bitmap this is. Or if this was allocated during my allocation tracking run, I can see the allocation stack trace, where this object came from. And for other classes, for example, string, yes, we show the actual string. So that's the new profiler. We hope it makes your apps better. And now I'm going to turn it over to Zav, who's going to show you how we're working to make your builds perform faster.
Thank you, To. All right, let's start with our new Maven repository. Finally, I know a lot of people ask for it. So the URL is maven.google.com, and starting with Gradle 4.0 milestone 2 that was released yesterday, you can just use the Google shortcut, so it's much easier, and you don't have to remember the URL. We are publishing all those support libraries and the Gradle plugin now exclusively through the repository, and we've uploaded all the previous version of the support library, not of the Gradle plugin yet. That will come soon. So you can just start using the repository even if you're not using the new artifact that we released yesterday. Then let's talk about build performance. We know it's a big problem for a lot of developers, and we've spent the last few quarters really focusing on that a lot. So the first thing that I want to talk about is making a lot of tasks more incremental. So we looked at the biggest tasks that takes the longest to run, and we looked at what we could do to make them incremental. So the Java compilation is actually part of Gradle itself, and as of Gradle 3.5, it's enabled by default, and it's stable incremental compilation. It doesn't yet support annotation processor, but it's something that we're working with the Gradle team to fix. Dexing in the plugin 3.0 is incremental on a per class basis and works with legacy multidex as well. So that will make a big difference. And then finally, APK packaging in 2.2, we released that as a incremental packager so that we don't have to recompress entries that didn't change from the previous build. And then we have a couple of tasks like resource processing. We are working on it using APT2. We've made a lot of progress. We're planning to release that for 3.0, for the final 3.0. And then shrinking, if you're using shrinking in your debug build in order to get below the multidex limit, we have an incremental shrinker that allows predexing and is faster than just running progard, so you can use that just for debug and do obfuscation with progard in release. So the second thing I want to talk about is the build cache. So Gradle in 3.5 released a build cache that works at the task level. So Gradle already looks at the hash of all your inputs and to see if the task is up to date or not. And now you can use that hash as a key in the cache. And if the task needs to run, but there's an entry in the cache, you're just going to get the output directly from the cache rather than rerun the task. So it will be faster. It should be stable in Gradle 4.2 and enabled by default at that point. There's two different versions of the task. The first one of the cache, sorry. The first one is local, so it's good when you're switching between branches, and you can enable it today with Gradle 4.0 using -- build cache or the property. And then the other one is the distributed one, sharing build cache with your teammate and your build server. For that, you need a storage backend. So they have a reference implementation on top of Hazelcast that you can use. Gradle Enterprise, of course, supports it, and there's a very simple API if you want to generate your own backend. So the Gradle plugin 3.0 Alpha 1 does not have a lot of cache that are right now marked as cacheable, only a couple of them, but we are planning to roll out more of those, and most of them by the time 3.0 is final. So that should make a big improvement. Now, a lot of developers are asking us, okay, how should I organize my project? How many components, how many modules, and how does that affect performance? So generally, more modules mean you can go around, lack of incrementality in some of the tasks. But it's also useful for other things, like code reuse, for example. If you want to share code across different applications, if you want to have better control over API and dependencies, like your business logic should probably not have access to some random UI framework that you're using, right? But in terms of performance, with caching in particular, then having more modules mean more chance to have a cache hit, and that's better. And also, there's something called compilation avoidance that was introduced in Gradle 3.4 that we're now using. I'm not going to talk about it. James and Jerome have a talk today at 5:30 talking about building up build speed, and they'll talk about it at that point. Now, we know that a lot of developers have told us, well, I'm adding more modules, and now my build is a lot slower, what gives? So this is really what we focused on a lot in 3.0, so I want to talk about that now. The first thing that we looked at was the startup cost of the build, right? That configuration time that happens every time you want to do a build or every time you want to sync. So we got a project from a developer. It's about 135 modules, 220 dependencies, and in 2.2 it took almost 3 minutes to configure, and that's pretty terrible. So we finally fixed that down to 10 seconds in 2.3, but even then we are still doing things that we shouldn't be doing, like resolving dependencies for all the variants, even though you may only build one of them. And we couldn't really fix it properly without a lot of new APIs. So in 3.0 with Gradle 4.0, we finally fixed that, and it's down to 2 seconds. We still have some room for improvement. There's some things that are not quite parallelized, but we'll do that later. So the other thing that we looked at was bottleneck when you have a lot of modules and you want to parallelize the build. And again, it's something we work very closely with the Gradle team. They did a lot of new APIs for us, and finally we can fix that. So let's look at an example here. Here on the left, we have some tasks that belong to an app that consumes a library, and the tasks are on the right. So let's go through what happened in the build. And we're going to basically build all the elements of the app, of the library, and then package them in a big zip file, the AR. And then we're going to unzip that AR, and we're going to consume it on the app. So you can see zero parallelism. That's pretty terrible. So again, with those new APIs that we have, now we can publish all those elements of the AR, and there's about like 14 of them, separately instead of just having to publish the full AR. And the build instead can look something like that. As soon as the manifest of the library is available, we can keep building the library, but we can start building the app too. And then you have better parallelism. And notice also that we don't build the AR at all anymore. We don't unzip it, so the build is also more efficient that way. And then finally, Gradle 4.0 has some additional APIs to do parallelism inside a single module. We're not quite using them yet, but we're going to start using them soon. All right, let's talk about some new build features. Oh, and I want to mention that it's just a first step, right? We're not saying 3.0 is going to fix everything, right? It's something we're going to keep investing a lot in, and it's just like a first step. OK, so some new build features. The first one I want to talk about is Job8 Language features. So it used to require Jack. We announced a few weeks ago that Jack is deprecated. In fact, in 3.0, Jack is completely removed. If you try to enable it, it will tell you don't enable it. The DSL is still there so that we have a proper message. All you have to set up is the source compatibility and the target compatibility. So the build looks something like this, right? We go from Java-C, which generates Java 8 class bytecode, to a converter that converts that to Java 7 class bytecode, transform, and then indexing. The transform is things like ProGuard, Instant Run, but also your own transforms, potentially if you use the transform API. So just as a heads up, later, probably in 3.1, we're going to reverse those two steps and do the conversion after. So if you have custom transform, you need to update them to Java 8 class bytecode as soon as possible. The second feature I want to talk about is dependency management. So there's a lot of changes here in 3.0. You're probably aware that if you have an app and a library right now, the library, the app only consumes the release version of the library always. So on the right here, you have the configuration of the library, debug and release, and then you have the configuration of the app, debug and release, and then compile and packaging. And you could kind of like go around that by manually setting up, debug compile and then targeting debug, and that would work. But if you use Flavor, it doesn't quite work very well. Now in 3.0, things are more complicated because for compilation avoidance, what we have on the library side is we publish 2 configurations per variant. So now we have debug API element and debug runtime that are meant to be used on the other side by compile and runtime, which were renamed to match the Gradle ones. So the good news is that we finally fixed that in 3.0, thanks to new API in Gradle, and now the stuff goes automatically. We don't have to manually try to make that work. So let's look to see how that works at a high level. Basically, we have the ability to set up attributes on those configuration objects, and Gradle will automatically match them. So we created an attribute on build type for you automatically, and then debug matches debug, and then release matches release. If you have flavors, same thing, right? We create a new attribute for the flavor, and then blue debug matches with blue debug automatically. You don't have anything to do; it's done automatically. Now, of course, if you don't have the same number of flavor everywhere, it's going to work too. Like if you don't have them in the library, blue debug is going to match with debug automatically. The attributes are actually optional. However, that's the other way around. If you have a library with flavors, but you don't have flavor in an application, then it's just not going to work, and you're going to get a build error, and you have to fix it. So we have a new DSL. It's called flavor selection. It's not variant aware yet, but we're going to do that, where you basically tell the build, look, I want to pick blue instead of orange, and then it just works. Now, if you switch to 3.0 and you have flavors, you're very likely to run into that error saying, hey, flavor dimension name is now required, which you may already be doing with 2 different ones, but not if you have a single dimension. So fixing it is very easy, right? That's your code, roughly, and then you fix it with that, and that's done. You don't actually need to put it in like flavor 1 or flavor 2 block because there's only 1 dimension. We can just fix that for you. So the big question is, why do we force you to do that? Why can't we just pick up a random default value? So let's go through an example. Here we have an app, and the app requires debug orange. And then we have 2 libraries, one of them with 2 flavors, blue and orange, and the one with strawberry and orange. Now you can already see that's not quite the same orange, right? And we just don't know. So when the app says orange, it's like, I don't know which orange you want. So that's why we ask you to name those flavor dimensions, because we're going to use that as the name of the attribute. And then the name of the attribute is actually color blue, color orange, and then fruit strawberry, and then we can make the right selection. And it's the same thing, right? Here, to make it work, you have to set a flavor selection. And in order to do that, you need to not just give us blue, but you need to give us color blue so that we can properly set that new attribute on the configuration, and then it just works out of the box. OK, let's talk about Instant App a little bit. So let's say you have an app. It has a few modules, an app module with that, the application module, some library module, and then you want to make some of those libraries as feature for your Instant App. So the first thing you're going to do is change some of those plugins to be not library, but be feature. It's a new plugin that we released. It's part of 3.0, right? And what's nice about that feature plugin is that it uses the attribute mechanism I just talked about, so that it publishes both a AR, or at least the content of the AR, for an app, and a feature APK. So when an app says, hey, I depend on you, give me your artifact, it adds to the attribute saying, I'm an app. And then it's going to link it to the right configuration, and it's going to consume the feature plugin as an AR. And when you have another module that is an Instant App, and the goal of that Instant App module is not to build anything, it's just to package, to grab all of the feature APK and make it into a bundle that can be uploaded to a phone or to the Play Store. Then the feature plugin will actually build a feature APK, something that can actually be distributed to your phone as a Instant App feature. And that way you can really share code without having to do some weird stuff. It's just the regular module that you had before, just change the plugin, and that's it. If you want more information about building Android apps, there's a talk at 3:30 today that I encourage you to watch. And with that, back to Jamal.
All right, so test. So now you've developed and built your application. Now it's time to test. So what we offer inside of Android Studio is a new performant Android emulator, which we actually released about 1.5 years ago. So if you haven't tried it since then, I highly encourage it. It's fast and exciting. But after launching the Android emulator, we found about 2 pain points from developers. One, developers want to try out their end-to-end flow. What's the experience look like, for instance, when my user actually downloads my app? Or perhaps, what's the experience of an in-app purchase? There was no way to test this. The second pain point was around Google Play services. It seemed every release, there was some lag between the Google Play services and the Android emulator. So to that, we added the Google Play Store to the emulator. Now, this seemingly small step was actually a lot of work. What we did was actually add a lot of quality and performance enhancements to ensure we had a great experience when using the Play Store with the emulator. Along with that, we also added support for OpenGL ES 3.0, which hopefully will help you accelerate your testing as well. And lastly, we added proxy support. I know some of you have enterprise networks or unique HTTP support. Now we have a UI that manages that. So I want to talk about the impact and implications of adding the Play Store. So we've always shipped the AOSP versions, or the Android open source project versions of the system images. What this allowed you to do is have unfettered access to both the operating system and your app by having elevated privileges and root access. But by adding the Google Play Store, we actually have a new variation of this called the Google Play Edition. And what this means is now we actually digitally sign the system images, but that prevents you from having root access. So if you want Google Play and Google APIs, just use the Google Play Edition. But if you want the deep analysis and root accessibility, you still have the AOSP version that's also available. One additional thing I want to talk about for the emulator is actually this new app bug reporting system. So we heard from some of you like, hey, I want to have a quick way to take a bug report, so perhaps I can share with my colleague or my QA team. So now, with 1 or 2 clicks, you can create a bug report for your emulator, take a screenshot, have some space to do a repo step, and put that to your QA team. So that should make it quicker for you to do development on the emulator. Lastly, for those of you who do Android Wear development, as you heard with Android Wear 2.0, we now support devices with rotary support. So we added a feature inside the emulator for you now to test that all inside the Android emulator. And lastly, about debugging is around the Layout Inspector. So as you saw from Tor's demo, we have a rich new layout editor, which allows you to add new constraint layouts and new themes and styles for your application. But many times you might have a problem with your layout. Something's the wrong color or something's invisible or gone. So we actually launched the Layout Inspector last year. But with this release, we added new capability for better search and better organization properties to help debug your layouts for your Android app. So lastly, optimize. So as you heard during the keynote, we talked about Android Vitals. And what this really is about the system health about your phone and the apps on it. And the way we think about this is actually sort of a continuum of information that's available. So as you get system health information now available through the Google Play Console or Firebase, now you have a list of sort of symptoms of what might be going on with your application. And now you can pop into Android Studio to have a deeper understanding of what's going on and have that root case analysis. And as Tor showed you, at the core of this is the Android profiler. So I hope you take advantage of all these various tools to understand, ranging from, again, the CPU profiler to understand what's going on with your CPU, the memory usage to understand what's going on with your memory profiler of your application, and lastly, the network profiler to get a deeper understanding of what's going on with your network traffic of your app. The last topic I want to talk about and optimize is around APK size. So as you heard on the keynote yesterday, we announced Android Go, and this initiative around making Android optimal and smaller. So many times with your APK, you might have legacy code or things going on with it you may not sort of remember putting into the app. So with 3.0, as Tor demonstrated, we've now added additional capability into the APK Analyzer. So again, I invite you to use this in your typical optimization flow. As demonstrated, we added support for instant apps, better bytecode support, program file mapping, and much more. And lastly, I want to call out a big feature around vector assets. So I'm a big fan of using vector assets myself, and it's a great way to optimize your application. But if you must use a bitmap or a raster image, we added WebP support inside of Android Studio. And what we found is if you convert from PNG to JPEG, you can save upwards to 25% in your file size, which can be a huge saving for your APK. So again, if you right-click on any PNG asset inside of our JPEG inside of Android Studio, we'll auto-convert it to WebP. And if you want to edit it, you can actually convert your WebP back into PNG. And with that, that's Android Studio. So we talked about a range of features from develop, for adding Kotlin support, or better Java 8 language support, better instant one support inside the build system, adding the Google Play Store to the emulator, and a whole suite of optimization tools for you. And with that, that's our talk. Thank you so much.